At the beginning of this lesson, there were 3 ways we could graph lines. One was the review from last year that we just talked about, okay, using a table of values. There's another method that actually is nice because you never have to worry about solving for y. You can actually find a couple of points without changing the equation. And this is something called the intercepts method. With the intercepts method, we only find 2 points on the line. We find where the graph crosses the y-axis and where the graph crosses the x-axis, and then connect those 2 points to form a line. Okay? So looking at this graph, at what point does this graph cross the y-axis? What's the point where it crosses?
4.
The point. Right. Good. So the point that it crosses the y-axis is 0, 4. And the y value of the point that crosses the y-axis is called the y-intercept. So we don't call the y-intercept 0, 4. We actually just call it 4. So understand the difference between what I'm saying is that the point that it crosses the y-axis is 0, 4. The y-intercept is just 4. Here's another point where where a line would cross the y-axis. Here's another point. Here's another point. Here's another point. Here's another point. What's common about all these points? Like, what's this point? So the y-intercept would be -1, but the point is 0, -1, right? What's this point? 0, -5. What is the x always? 0. That's important. X is always 0. Similarly, what's the point? The point, so 2 numbers, where this line crosses the x-axis? -2, 0. And the x value of the point that crosses the x-axis is called the x-intercept. But when we talk about the x-intercept, we only say -2. We don't say -2, 0. What's the y value of every point on the x-axis? 0. So we can actually use this information to graph equations using this intercepts method. Right? Before I write out these steps, let's look at an example first. So let's say, using the intercepts method, we're asked to graph this equation. Well, we're going to find 2 points of this equation. We're going to find the y-intercept, and we're going to find the x-intercept. And we're going to plot those 2 points and draw a line through them. What was the value of x at every y-intercept? So here's what you do. Plug 0 into the equation. So instead of x, it's 3 times 0 minus 2y equals 6. Well, you're handing them out. I'm just going to take. Okay. What's 3 times 0?
0.
So that just goes, disappears. How do I solve for y here? Divide by.
-2.
Therefore, the y-intercept is going to be what? And what point on the graph is this? It's 0, -3. So plot that point. But I need 2 points to draw a line. So I got to go back and find out where it crosses the x-axis. What's the value of y at every x-intercept? So use the equation again. 3 times x minus 2 times, well, y has to be 0, equals 6. Well, 2 times 0 is nothing. So it disappears. So I'm left with 3x equals 6. How do I solve for x? Divide by 3. And the x-intercept is 2. Which means it's at the point 2, 0. So plot that one. You got 2 points now. Draw a line through it. Yep. Sure. Okay. Biggest mistake students make with this. They think that these are the 1 point. So they'll plot 2, -3. And then they'll say, okay, well, how do I graph a line? How do I know which way it goes? Well, you can't. You can't graph a line from 1 point. How do you know which way it goes? You need a second point. Remember, we're finding 2 separate points. The point where it crosses the y-axis, the point where it crosses the x-axis. So, what did we do? Find the y-intercept by making x equals 0 in the equation. And solving for y. That's 1 point. This is 1 point. Go back to the equation, find the x-intercept. By making y equals 0. in the equation. And solving for x. This is a second point. Once you've got your 2 points, plot the 2 points and draw a line to them, which is what we did in that example. Okay. So before we finish this up, go back to exercise 3.5, number 5. Let's do an example together. Let's do one more example together. Let's do B, 5B. Notice the instructions say use the intercepts method. So remember, when you use the intercepts method, you're going to find the y-intercept by making x equals 0, and you're going to find the x-intercept by making y equals 0. Then you're going to plot those 2 points and draw a graph. What does the equation look like when I make x 0?
-2 plus equals 0.
Right. Because this is nothing, right? So solve that. How do I solve -2y plus 4 equals 0? Subtract 4 from both sides. So I get -2y equals -4. And then,
Divide -2 both sides.
and I get y equals 2. That's the y-intercept. Plot it. Don't start the x-intercept until you've plotted the y. See if you can find the x the same way. I'll let you guys try it. Sure. Yeah, that's fine. So see if you can find the x-intercept. Yes. Yeah.
How did you get
Okay, so to find the y-intercept, make x 0. So that means that just disappears. There's nothing, right? Oh no, ignore the x because it's become 0. So solve what's left. Solve for y. You take away that and solve for x. The x, whatever. So yes. So for the x-intercept, you take away the y. So this 2y, and you'd be left with x plus 4 equals 0. Solve.
Different lines at first?
Where do you get it? Oh, yeah. Everybody finished with this? Yep. So what does it look like when I make y equals 0? Well, this minus 2y completely disappears because 0 makes it nothing. So I'm left with x plus 4 equals 0. Therefore, x-intercept is -4. So put x equals -4 on the graph. There's your 2 points. Draw a line through them. And you're done. Like I said, this is a good method because remember with the table of values, we had to get y by itself. So we had to do some algebra. Okay, this way we don't have to. We can just use the equation right away. I would strongly suggest that you try A and C right now as well, just to make sure you've got a handle on it, please. And exercise 3.5 should be done by Wednesday.